Good evening. We'll start our lesson on how to draw an isometric figure using the boxing method. Using the boxing method, how to draw an isometric view in 2D approach. So we'll have a go at it. This is our AutoCAD. We know this window by now. We are familiar. This window, we have been using it for quite some time. Then we want to draw this figure. So this is our orthographic that we've been given. Then we'll draw this box, and we want to put these views. This we call it plan view, and this front view on this isometric, and then we end up with this isometric view, which shows most of the details of this orthographic presentation, having been transferred from orthographic to isometric. We have been familiar using manual drawing. Now we want to approach this using AutoCAD, computer aided drafting. So we go at it. So what you do, you open your AutoCAD and you see this window, this model window is showing XY plane, means it's showing what? A 2D plane. So you want to go to a 3D plane. So you go to view, 3D views, southwest isometric, and there is your isometric view, viewport, right? Which will show most of our details of our feature. We can see it. So we want to draw this box. So there are so many ways of approaching it. I would approach it this way. This is 70 by 160. That's the length and width of the rectangle, and this is the height of the box, 60. So I would draw the rectangle first, which is 70 by 60. So I come here, I say rectangle. Then what is my start point? Start point is 0.0, and it goes there. What is my second corner? It will be 160. The x is 160 by, what was it, by 70. There is my rectangle. So I zoom it. So my rectangle has come out, which is this one, 70 by 160. So in that, after that, I can draw this vertical line, 60, 60, 60. Then I join, or I can just, yeah, that's the easiest way. So I go to my AutoCAD, I will draw line, and I turn auto on, right, so that it just gives me a vertical or horizontal direction of going. And my height, let me check, my height is 60. So I come to AutoCAD, I go 60, and then I can leave that command, and I go to line again, I come to the origin, press, I go height. If I remove auto, my line will not be easy to pick the perpendicular. So I should go auto on. then it's automatically going to pick the perpendicular, and I go height 60, and I go enter, right? Then I go out of the command, I come to line again, I draw line perpendicular 60, then I go enter, come out of the command, right? Then I will now join these lines, or I can go to line again, I go to this, I go auto in this direction, and I go 160, and then I can come and join this line, come out of the command, I go to line again, I can join this point and that point and that point. Now I have my isometric box, right, which is this one, isometric box. So box with the overall dimensions to fit. This is the box, this is the box that I have drawn. Even if you try and dimension it, you find this is the box. So my duty now, next step, is to draw either this front view or this top view. Choose whatever you want. Let us say I want to draw this front view. So how it is stepped, it is 20 there, it is 50. So it will be, I'm sure, I think this is 170, this is 20, 20, 20, making it 60, plus this 100 makes it 160. So here's 50, here's 50. So I can come my AutoCAD and pick this line. I can use offset. Sorry, because now I want to use this. This is my top, right? And that's my bottom. This side is my, I want to call it my southern end. This is my northern end. This is my western front. This is my eastern front. I want to draw on this eastern front. So my UCS, user coordinate system, should shift. In AutoCAD, when you are drawing, always you are drawing in XY plane when you are drawing your 2D. So if we are going to draw in this eastern side with the ZX plane, our XY should be in this ZX plane. So we should shift that so that our XY is now along the current X and Z. So how do we do that? You write UCS, user coordinate system, then you press enter. Then it says specify origin of UCS. I don't want to change the origin. This is the origin. Then specify what you want to be your x-axis. This. Specify what you want to be your y-axis. This. If you check, my xy plane has changed. I might want to repeat this. Let's do undo, right. So what do? I type UCS, and then the origin is this. Then specify point on x-axis. I can specify any point. Specify point on xy plane. This is the xy plane. And so this is my new drawing plane. So if I offset, I draw anything, check, it will go on that plane. You see the circle. This is no longer going on the old plane, it's going in this plane. So that is, I can take this line and I can offset it along the same plane, because this is the measurement. If I offset here, it will come I offset it to 20, then I offset again 50, I can do that, offset again 20, they offset again, and then I have all my lines. So the first one is this 20. So I come to my AutoCAD, I say offset, specify offset distance 20, and select object, this is the object, select side, this is the side. See, then I come out of that command, then I want to offset this from there to there, it is 50. So I come again, I go to offset commands, then specify distance, now it is 50, and specify object, this is the object, specify side, this is the side. Come out of that command, again I go again offset. Why I'm coming out of the command is because I want to change the distance. Specify offset distance 20, and specify select object, this is the object, select distance side, sorry, this is the side, right? So I'm now on this one, I've offset this one, I want to go to 50, the last one. Come to AutoCAD again, I go to offset, then it says offset distance, now it is 50, and I press enter. Select object, this is the object, select side, this is the side. See, now I have managed to draw these lines, but we want to create this dimension, which is, this is 20, if this 60 means the difference is 40, so from there to there it is 40. So we can come here to our AutoCAD and we can draw even a line along this, anything you can do, right? I want to use this line, you'll see how I'm going to use it. Then I'm going to offset it, select offset, then it says distance we agreed is 40, and select object, this object, select side, this is the side. Very easy. Now we want to do some trimming, because we want to leave out box 1, box 2, which is this. So I want to trim. Someone wanted a line, so we go, I told you trim before, you press TR, go to command, escape, you hit command, you press TR, then you press enter twice, enter, then it gives you the trim. Trim this one, it's not trimming. Let's start all over again. Right, so we want to trim the unwanted parts of our lines, so that we leave the wanted edges to create our profile. So we go to trim here, click trim, then it says select objects. I can select this object will be my trimming edges. Yes, some edges I want to leave. Alright, I'll select this, select this. This will be my trimming edges, right? Then I press enter. It says trim the object that you want to trim. So I want to trim this, I want to trim that. Let me go to my drawing again. This I must leave, this I must leave, but all the short ones I must trim. So I come to this short one, I trim, come to this short one, I trim, come to this short one, I trim. Then my feature is almost there. Come to this long one, I trim, this long one, I trim. Then I'm almost done. Then I come out of trim command. This feature, if I come into my box, this line, these lines are not there. So I come here, I want to trim off these parts of the line, right? So what do? I will go to trim command, then it says select objects. I want to trim the cutting edges that I will use to trim. These are my cutting edges. Then I press enter. Then I trim this one. No. I cannot trim it because it is it is a polyline. So I must make sure that I explode that rectangle. So let me come out of that. I select this, then I say explode. It is one entity, there's another entity there. Where did this one come from? Let me delete this one. Alright, fine. This one entity, this one entity, this one entity. Now I should be able to trim it. So I go to trim, then I select cutting edges. This is my cutting edge, this is my cutting edge, this is my cutting edge, this is my cutting edge. Then I say enter. Let me go to it again. There it goes. There it goes. Right? Then in isometric, that part is not viewed. So if you want, you can draw this line here, because that's the part that's going to be viewed. Now let's check. Let's go and check first. Yeah, you see, this internal is the one that's viewed. That other line is not viewed if it's in isometric position. To be hidden edge. So this edge is not viewed, but this edge is viewed. So we draw a line which is parallel to that auto. As long as your auto is on, you are not affected. So there is your line for this edge, this one, right? Then for this edge, we draw that line. So we go to our AutoCAD, we go line, our auto is on, and we draw this line, and it should cross over, right? So this line is not viewed. Let us deal with that later, right? So we want to trim these lines. So the other way to do it is just to come here and you redraw again the line up to there. Then you redraw the line again just up to there. Then you delete these longer lines. You delete this longer line, delete that longer line, and then again in isometric, let's go. There is this edge is not viewed, right? You can see here that edge is not viewed. Again, this edge is not viewed. this edge. Sorry, this edge is not viewed. You can see it from here. It is not part of the view. So what do? You just come to AutoCAD, just click this, you delete it. It's not viewed. Click this, you delete it. Nice. The view is almost there. Then you got circles, check, that are on top here. These two circles, and these two circles indicate two holes that are through holes that are shown here. So how do we do? First we draw these two circles, then we offset them. How to draw those two circles? Our UCS is to come to this plane, and this will be our drawing plane, and this is our start point. Any of these 4 points can be our start point. This will be our start point. So if this corner becomes our start point, in orthographic this is the corner. So you can calculate the center of the circle. It is in the middle of the 50, so it will be 20 plus 25, it will be 75, right? Then from this edge it will be again 20 plus 25, which is what? Which is 45, sorry, 45. 20 plus 25, it makes it 45. 25, I'm getting it from this 50. If we divide this 50 by 2, it becomes 25. So that I have, and the 20 makes it what? 45. So from this corner, that center, it is 45. From that edge to that center, it is 45. So from that corner to that center in terms of x, to be 160 minus 45, which will be 140, 135, right? So we want to move our UCS. So we've known our two centers. The first one is 45 from this corner. The second one is 135. Is it? Yes, it is 135 from this corner, but it is in the midpoint, in the central axis of the top plane. And the diameter of our circle, is it given? Let's check. Yes, diameter 50. Right. So let us move our UCS. UCS is down here, and the XY plane is on the vertical side. We want it to be on the top. So you type UCS. Very interesting. And you press enter. Specify origin of UCS. This is our new origin. And specify what you want to be the x-axis. This. Specify what you want to be the y-axis. This. Check. It's now in the very correct position, very correct orientation. So we draw our first circle. So we go to circle. What is the center of the circle? Circle along the x to be 45 as we have agreed. So we type 45. Specify center. Specify center point is 45. And then along the y-axis, it will be, let me check, it will be half of 70, which is 35. So along the y-axis, it will be 35. And there is your circle. Then our circle radius will be 25, since our circle diameter is 50. There is our circle. Nice. Our first circle has come out. Then our second circle, we agreed it is 135 along the x-axis, and it will be 35 along the y-axis. All right, or yeah, we can do that. Let's go for it. So we go for our second circle, and then we say specify center. It will be 135 and then 35. It's our second circle. Then its radius we specify 25. If it's already there's no need to re-specify. There is our second circle. It didn't come out exactly where we want it, so we delete it, we recalculate it. Let's go and see. So this is 160 and our age is 45. Was 45 from 160? Oh, it was my mistake. It will be 115, not 135. 45 from 160, it's 115. So we go to our AutoCAD, we go circle, and the center is 115, not 35, and it's our center. Then our radius is 25, and is our second circle. Right? Then you, in isometric, if you view it, these circles, it's a hole. So how you view a hole is isometric. Those two circles will be like two offset circles, but part of it is hidden. So how do we do it? We can now have a plan of drawing the other circles which are underlying there, and then we trim the unwanted part. Then our drawing is done. We will be complete at that point. Now we've drawn our circles on the top plane, but we want to include these edges to show that the top plane is depicting a through hole. This orthographic view is depicting a through hole. So we want to show that on this isometric plane. So we have to draw these two parallel holes that are 20 millimeters from the top plane. So how do we do that? So we come to our AutoCAD. You see our UCS is in the top plane, and our XY plane is in the top plane, and then Z goes up. So what we can do, so many ways of killing a cat. We can just move the UCS so that it is in the same parallel plane as the top plane, but 20 millimeters below. So we just do that. So we type command UCS, user coordinate system, and then we type M for move, and then it says specify new origin. I just come here. If I want new origin, I just type 0, then 0, then minus 20 for Z. There is my UCS. See, if you want, I can repeat that. Let me undo that. How to move UCS from this top plane. We don't change the X and Y coordinate, it remains 0, 0. But we want to change the Z so that it comes to minus 20. So when we move the UCS, the new coordinate of the UCS has only changed in Z. The X and Y remains the same, right? So we go UCS, enter, and we type M for move, enter. Then we type the new origin, so we go 0, 0, minus 20, enter. Then there is our new coordinate. See, very new coordinate. Nice. Then so we want to draw 2 holes which are parallel to these 2 holes but 20 millimeters apart beneath, and we can simply do that because they will share now the same center in terms of x and y, but they only have a difference in z, and the diameters are the same. So we go to hole command, circle command, and what is the center of the circle? Specify center of circle. You can specify coordinate wise. So the center will be, go for it, our center, it will be in x, it will be 45, and in y it will be 35. There is your circle, right? Then what is our radius? Our radius will be 25, and see, there is our first circle. Then the other one will be in line with this one, beneath 20 mils. It's very easy because our UCS is already in that position. So we go to circle command. For our center, we go, last time we did for x it was 115, comma, and then for our y is 35, enter. Then for our radius, it is what? Our radius is 25, enter. There is our 2 parallel circles, parallel beneath these 2. Now we want to trim them off so that we remain only with this, to show that it's isometric. This is the only visible part of the whole. So how do you do that? Come to AutoCAD, just zoom this. I want to show you the trick. You can just draw a line here, small line joins this part and that part, right? And come here again, we draw again another line which joins that part and that part. Come out of the line command. This line I've drawn it so that we use it to trim off the unwanted part of the circle, right? And this line, trim it because it is in the same plane as the circle. We cannot use this circle to trim this one because they are not in the same plane. So we have just drawn a line which is in the same plane but will be useful for our trimming commands. So we go to trim command, then it says select object. This is the boundary, this is the boundary. Then we say enter. Select object to trim this circle, it's gone. Trim it again there. No, this time is not good. Let's see. Oh, sorry. Let us undo that. Let us undo that. Right. So we go to trim. trim this edge. We select this edge. Here is our, then we select again this edge, and I say enter. Then they say which one to trim. This one to trim, that one was successful. This one I want to trim, this one was successful, and this one I want to trim. Why is this not coming up? Maybe it's not touching, but still we can undo that, and we can come here and we go again, trim. This is our fencing side. Oh, maybe that line is not crossing there, so for that we can just maybe draw another line to assure that it crosses there, whether it's in auto, and put it in auto. Right, so we try again, trim command, and this is our fencing, and this is our circle. Oh, it's not being trimmed. Let's have a look at it. So it's not being trimmed properly, that edge. So as I told you, there are so many ways of killing a cat. You can remove this line because maybe it was not forming a proper cutting edge, and you can draw another one which stretches right across the point desired, and you can stop it there. So this one crosses our circle, but we want it to cross right at the intersection of this, so we delete this. We try and get something that crosses right at the intersection. Right, want to make sure that it crosses right at the intersection. Good. No, it's not behaving the way we want it, because we want a proper trimming edge, so we must be assured that it's moving across. So we have to come and then click somewhere there. There we are. Then we have made sure that our trimming edge is going across the point of intersection with the edge that we want to trim. So we go again for trimming, the last command. So we pick trim, then this is our trimming edge. We press enter, go ahead, trim. This one was the stubborn one. You can try and click now, and now it is gone. See, now this, we don't want this, so we delete, just delete straight away. We're just using them for trimming. We don't want this again, delete it, and then check. This is our isometric using the boxing method, and we have converted this orthographic to this isometric by first of all drawing this box, and then we go side by side, moving our UCS to the front and to the top to draw the two holes at the top and these two slots that are on the sides, which is the front. So with that, we want to make sure that you are now assured to practice. You are now assured of being able to use the boxing method to draw an isometric view of a given orthographic view. So you might want to put it in your own template. You might have drawn your own template. You might choose a template from AutoCAD. Then if you want to choose an AutoCAD, you come here, you go, you put your cursor on layout, you right click, it will say from template. and from there you can scroll. I usually like the ISO. Let us say you are asked the specific template, so you have to go to the specific template. I usually take this ISO A3 color dependent, right? There is the template, right, for printing. So if I go to this template and then I go view, 3D views are not there. I go to this template, so I click inside, my object will come right inside, right? As you have seen what has happened, it has come right inside. So this model, I've created my template. I showed you how you create your template. This is your model and you want to put it on a template for printing. So you come here, you choose views, 3D views, southwest isometric, and then it comes automatically. It comes right. There is your drawing. Now if you double click, I'll show you. If you double click outside, now you can zoom the whole template. If you double click inside, you can zoom only your drawing which you created to put it in the position you want. If you zoom outside that margin here, which was bold, it's no longer bold. If you click it, sorry, let's go to model again, right? If you click the inside, this margin is bold, and you can zoom your drawing, your isometric view, and zoom to make sure it is the size that you want, right? But if you click outside of the box, it will make you be able to zoom the whole title block, right? If you click on this print here, it will enable you to edit the attributes of your title block. So you see that if I edit here, file name, I put, let us file name, let us say it is what, a bracket, we just put bracket. You can put it in caps, put bracket, and say okay. You find under file name bracket is there. Here is bracket, right? Let us say I change all these attributes. Let me double click the car file name. I've changed. I go to drawing number, I put drawing number 2, right? And I go to owner of the drawing, I put GMT is the owner of the drawing. Then I go down a little bit, checked by MMGG, whatever name you want to put, right? Then you see it's changing the attributes. Designed by, you might say engineer Tom, whatever you put, right? Then you say date of approval, you put any date you want. This was 21 May, sorry, 21 May 2021, right? It's coming up. All these attributes change. Date you put, everything you put. I have no time to change everything, but if you say okay, you find there is your title block, your template having what, being edited to your desirable specifications. Now you want to print it. So you realize now this is usually we just draw, as I told you before, we draw on a scale of 1 to 1. Then our drawing size will change according to the paper size that we've chosen. Like here we chose A3, we can choose A2, we can choose A0, and we can zoom our drawing to suit the paper size. Correct? Now let us now go to printing. So you go to File. If you want to save, first of all, you want to save as. You go to wherever you want to save. You want to save it in desktop, in a folder called Blow, and you give the name of the drawing, GMT 2020, and you say OK. It is saved. This is a template drawing which has been saved, TWG. Now we want to print it, so we go to File, you go to Plot. Here is where you choose your plotter. These are the type of plotter that might be there. Sorry, not the name. So this is not the name. The name here is the print plotter you choose. See if you've got any. I'm not connected to any printer, but the Forex PDF printer I've got, which is the PDF converter. Then you go to paper size, you say fit to paper size. Then you go to other properties, is a properties like this ones, custom. Here I'm targeting the layout so that I can the paper size. I want to print it on an I want to find A3 paper size A3. I want to print it, and then the units I want to change them to millimeters. Then I want to put it to landscape, portrait, landscape. These are the most important parameters to change for printing. And you say okay, then we want to, this is one method of how you choose your plot area. The popular one, you practice some of them, like display, extends, layout, window is the popular one. It allows you to choose the window that you want. So this is our first corner of the window, and then this is our second corner of the window. It gives you a preview. Click preview. There, it's going to come out in your printer. If you don't want it, you can change it. If you want it, press escape. If you really want it, you say okay. Then it's printing, and it's printing in what? In PDF. We give it the name, any name we want to give it. GGG, MMM, TTT, just a name. 2020. Then we say save, and there is your printout. Check, everything that we edited is there. So that's how you go about when you are practicing of converting with our PowerPoint. Somewhere here, this one, when you want to convert from orthographic to isometric using the boxing method, where you draw this box and you transfer these views on the appropriate views, so that we have got this in the end. Thank you very much. Take time to practice. You will get this done.